like the cloud abstracted away the complexity of maintaining hardware and so on, EigenLayer abstracts away the complexity of the operator set, the amount of stake. Do you have to have your own new token? No, you don't. But if you want, you can also have it. So the amount of flexibility and expressivity that EigenLayer gives you basically enables you to express, and abstract away things you don't want to deal with, and then like focus on the things that you do want to deal with.
Hi, everyone. Today we have Sreeram and Jessy from the EigenLayer team. Sreeram is the founder and CEO of EigenLayer, and Jessy is the ecosystem lead. You may also know her as 13-year-old VC from Twitter. So welcome, Jessy and Sreeram. It's a pleasure to have you on here with us today.
Thank you so much, Austin. Ada, great to be here.
Likewise.
Super. We're starting this new series, so it's very nice to have like super influential guests. But yeah, to start off, EigenLayer launched it to Ethereum mainnet on June 2023, and there's almost 8 billion in total value logged as of today. And I just actually remember it being like a billion a few weeks ago, so that's quite a significant amount and pretty exponential growth. So congratulations on these milestones. And I feel like given the buzz and excitement around EigenLayer, many people have heard about EigenLayer and restaking, but most of the discussions are pretty high level. And given like the complexity and the concept being very new, there's just a lot to unpack and deep dive into. So the goal with this conversation today is to deep dive into what EigenLayer is, why it matters, and to also explore the opportunities in the EigenLayer ecosystem for anyone thinking, I think this is very cool, but where do I get started? So with that, I'd like to start off my first question and address it to Sreeram, if that's okay. So what is EigenLayer and restaking?
EigenLayer is a mechanism to allow anybody to build new decentralized protocols on top of, the Ethereum trust network. So when you want to build a new protocol, but you cannot build it as a smart contract on top of, Ethereum or any existing blockchain, you need configurability and programmability where you need to specify what each of the node is doing. Maybe it's a new consensus protocol, a new oracle, a bridge, AI inference. Maybe it needs some special hardware like running an Intel trusted execution environment. Any of these things. Today, you would have to go and like build your own network to do this. Instead, EigenLayer is a mechanism that allows builders to lean on an existing, trust network. And what do we mean by an existing trust network is in the Ethereum protocol, a lot of ETH is staked and there's a lot of operators. And can these participants and the stake secure new and other protocols? That's what they can do through EigenLayer. And why would they do it? They would do it because they are getting, additional rewards from these other protocols, either through fees or native protocol emissions. And why would we be able to trust the answers and networks that these nodes are running? Is because if they don't run these nodes properly, EigenLayer has a mechanism to slash them, which is to impose negative penalties on it. So thus, you can think of EigenLayer as a coordination mechanism to bring stakers, operators, and ideas and builders together to offer and create new services for the broader crypto ecosystem and particularly the Ethereum ecosystem.
And I think mostly we're going to be thinking of things from the developer standpoint and the kinds of things we can build on top of EigenLayer. But first, I want to take the standpoint of a node operator. I've got my node running over here, and the balance of risk versus reward here. And I think there's a subtlety to that, right? We're basically extending the trust network or the security of Ethereum to build more things quickly, which is awesome, and that gives us more yield. But then there is some risk there that's involved. So maybe not even from the developer standpoint, but just from the staker standpoint. I'm running a home staking node. What is the risk there? What am I thinking? What are my incentives?
Yeah. So there are two ways of staking on EigenLayer. One is native staking, where you stake in Ethereum and then set the withdrawal address through the EigenLayer contracts. The way to think about it is you're adding one step in your withdrawal flow. So instead of directly setting your hardware wallet or whatever to withdraw when you exit from Ethereum staking, the money goes through the EigenLayer contract and then you withdraw from there. So why this is, this allows the EigenLayer contracts to impose negative penalties if you opted into a network and did some malicious activity. There is also liquid staking, where like you can take a liquid staking token and then put it onto the EigenLayer protocol, and delegate an operator, or you yourself run node operations to actually secure it. So that's the scope of the EigenLayer kind of staking and operating. And if you're a home operator, what kind of additional risk are you taking? Firstly, you should have enough hardware to actually run the other services. So that's obviously a requirement, not a risk. And then why would you spend additional compute in running these other things? Because you're getting rewards, and you look at the reward schedule for the other protocol, whether that is they're sending you a portion of the fees, or whether that is they're sending a portion of the emissions or whatever from the protocol. It is transparent and clear on the EigenLayer system. So you can look at it and see if it is good enough for you to opt in. What is the risk? The risk is, of course, that you get slashed, right? And there are really two fundamental risks as a staker. A hack on the EigenLayer contract might leave your tokens exposed, right? So that is one possible risk. The other one is you will get slashed, and you could get slashed either legitimately for actually a malicious action you did, or illegitimately for some action you did not do, but the contract adjudicates that you did. And so the protection we have on the last one is the slashing veto committee, a committee that has to manually authorize like a slashing before it actually is implemented. So, but the committee unilaterally cannot impose slashing. A committee can only authorize an existing slashing which is triggered by a contract. So you can think of it as like a two-step check. Contract has to trigger it, committee has to approve it, only then you get slashed. So if you trust either the committee or the contract, you're okay. So we are in the balance of powers across AVS or services and stakers. We lean towards staker safety, because if stake is not safe, nobody's going to stake, and then there's no service to be built on top. So okay, so that's the risk. On the first risk, which is what if the smart contract got hacked and your kind of money can get stolen? And we take a lot of precaution, but one of the most fundamental levels of protection in EigenLayer is any withdrawal out of EigenLayer takes 1 week. So there is a escrow. You have to initiate a withdrawal from EigenLayer and then sit around for a week, and then only you can take the funds out. And the reason we have this is, in the worst case, if something bad happens to the contract, there is a security council comprised of people from all around the space, including some from the Ethereum dev team, but also Coinbase and Figment and all, participants from, and then people building on top of EigenLayer. They can actually veto and, or rather pause and upgrade the contracts. So that's called the security council. We have a 13-member council for that. So these are the checks and balances. And, as anybody building a smart contract system knows, there's always inherent risks, even, if you're using natively on Ethereum. But judging the risk and being able to understand and, opt in to the set of things that you're actually interested in, that's what EigenLayer allows expressivity for.
I think that's a great intro. So I remember hearing about EigenLayer almost a year ago, and it was pretty unique because it opens up it allows to bootstrap new tools, new services, new networks much more easily and faster. You don't need to get that many people. You can kind of use the decentralized trust, or more like this capital, the economic capital and the staker set of Ethereum. That's kind of how I understand it. So they're basically stakers, and then there are these new services which want to be built. So you can kind of say, through EigenLayer smart contracts, you can use the stakers and the economic capital and then run your own services. And just to kind of touch on the services, from my understanding, is not necessarily consumer apps, but more the apps oracles, bridges, more apps which kind of the services which consumer apps might require. Do I have it correctly? Am I missing something? I think there's still a lot
No,
more to
I think this is a really good phrasing of the structure of the market. So you can think of like, from a crypto native viewpoint, you can think of this as middleware services, all kinds of middlewares like bridges, oracles, running other kinds of like I want to have a co-processor which runs a certain inference protocol or run like, other languages and so on. But, there's also an analogy we can make to the cloud. And in the cloud, if you're building an application, let's say back in 1995, like Amazon was building a bookstore, right? But Amazon had to build their own server. They had to build their own login protocol. They had to build their own payment protocol. They had to build their own database. And then on top of all of this, they built their bookstore. So, but in 2024, that's not how you'd build a web application. You'd probably use the cloud like AWS, probably use a service like, database like MongoDB, like a SaaS, software as a service, is like an emerging category of all kinds of interesting services that are built on the cloud that you can just like plug and play. Maybe you use Stripe for payments, you use OAuth for authorization, right? And then you build only the new and interesting different thing. Like let's say you're building a shoe shopping site. So you only build that thing that is not already there. So what the software as a service category did is to enable anybody to build and deploy interesting services without having to worry about, oh, I need to maintain hardware. I need to maintain cybersecurity for it. I need to keep upgrading the hardware. I need to coordinate across the cloud. All of these other things abstracted out. And so you just, as a creator, developer, you focus on what really, really, you are good at. So leads to hyper specialization, right? And, when people think of, are we, when people say, oh, is it modular or monolithic blockchains? This is a debate that people have. I think it's a very narrow view of what modules exist. People think maybe there is like, settlement, data availability, and sequencing or something. But actually, we think the right analogy is to think about the SaaS, software as a service stack. In the cloud, you see thousands of successful SaaS services and hundreds of unicorns. That's the scale of like specialization. As an example, somebody would build here is a NoSQL database for streaming data to an AI service. That's the specialization level we are talking about. And somebody is building a SaaS service. And, a typical end user or consumer application builder will integrate something like 15 SaaS services in the backend. People in our area get a little bit flustered and say, oh, you're going to have so many intermediate layers of payments. Yeah, like that's how the cloud works. Because, if you just look at the large arc of civilization, it's, people get more and more specialized in what we do and more universal in what we consume, right? And that is just the arc of all technologies. There'll be somebody who's hyper specialized at, building something like a decentralized data lake for AI applications on crypto. Like that would be something super special. And why should that be that like there is like one integrated stack that has everything that you want? So that's the vision is builders, we call these AVSs like SaaS, right? Actively validated services. So to distinguish it from, staking was used for all kinds of things in DeFi and this and that, but our particular goal is to only do decentralized and active validation. So we call this actively validated services. So anybody who wants to build an application which requires significant amount of like control on how to program and build it, they can actually build it and deploy it on top of like EigenLayer. And just like the cloud abstracted away the complexity of maintaining hardware and so on, EigenLayer abstracts away the complexity of the operator set, the amount of stake. Do you have to have your own new token? No, you don't. But if you want, you can also have it. So the amount of flexibility and expressivity that EigenLayer gives you basically enables you to express, and abstract away things you don't want to deal with, and then like focus on the things that you do want to deal with. So that's, and as a downstream consequence of this is, as more and more AVS services emerge, an end user customer application may become very similar to an end user customer application in cloud today. You just integrate a bunch of good SaaS services and then build only the diff, the things that are not there, and only that you build and deploy. And so that's our kind of long-term vision for how this might play out.
That's a great analogy, and I definitely resonate. Like, I remember reading like it unlocks innovation at the infrastructure layer. So that's kind of I read the analogy and it really makes sense. Like, I remember people also being afraid of cloud like just 10 years ago. So that's funny. But I kind of want to ask about the operator side, because we talked about the stakers. So they're the stakers who can kind of opt in, like they can do native restaking, or they can like liquid restaking to kind of use their liquid staked tokens. But the operators, I think they're also different. So they kind of have to, like, what are the incentives of being an operators and the requirements as well? Because I guess it depends on the services. So can you talk a bit about that side of things?
Yeah, absolutely. How do you become an operator? Operator is a permissionless role on EigenLayer. So, you can just come and say you're an operator. But it requires people who have stake to delegate to you. So it's incumbent on you as an operator to get either your own stake that you can delegate to yourself, or other people, if they are delegating stake to you, they need to trust you. And this delegation mechanism, the trust for delegation between staker and operator, is not inbuilt in the EigenLayer protocol. So, which means, just because somebody is an operator on EigenLayer doesn't mean you should go trust them. Like, you need to have external world trust to know and vet, here is a good operator. Otherwise, you should not delegate to them. It is staking and delegation is non-custodial, so it is not a risk that they can take your capital. But the risk is they don't do their operations properly, and then you get slashed, right? So that is the risk. So the native structure of EigenLayer delegation is somewhat similar to Ethereum in the sense that there is no native mechanism to vet delegates, but it is different from Ethereum in the sense that in Ethereum doesn't even expose the information of, the staker is different from like an operator. It's just one thing. And it's out of protocol relationships, which actually build them as two separate entities. So we have specification, or the information is exposed, but not used to actually do something specific. So you have an operator, you go, if you're a staker, you stake, and then you find one of the operators that are offering or opting into the set of services that you want, you can delegate to them. Like, that's the mechanic. If there is no such operator, then you have to either do it yourself or find somebody you trust to do it for you. As an operator, it is so right now, if you look at major operators, one of their big pain points is every new chain that they're going to market with, they need to attract a new token holder and a new consumer base to actually come and delegate to them. That's how it is, right? So I want to be an operator for Atom. I want to be an operator for Osmosis, whatever. Like, each chain has a different token holders and community that, as an operator, you have to do separate BD, like business development too, to actually get those things. EigenLayer is ETH stake. Really simple. So if you target ETH stakers to come and delegate you, you can just offer more and more services. So as an operator, is actually really convenient economics. So that's the operator side. From a staker side, like I said, the trust relationships to an operator are not in protocol. There are interesting out-of-protocol mechanisms coming up, like liquid restaking token is one of them, where a liquid restaking protocol basically vets a group of operators. You just put your token in, and they do all the work to actually find a list of operators and which set of AVSs they're serving, and how to whitelist them. All of these things are offloaded to some kind of a decentralized protocol called a liquid restaking protocol. And this can be convenient, but people have to be aware that they're taking a trust assumption on the governance of these liquid restaking protocols to make these judgments correctly. So as a holder, if you're engaging with a liquid restaking protocol, you have to make sure that you are comfortable with the assumptions that you're making there. That's a kind of a user experience simplification that we have as an emergent consequence. We did not do this ourselves. We don't run a liquid staking or restaking protocol or anything like that. Outside the protocol, there are some people who actually participate in these kinds of services.
That actually brings me to another question which I had. So I see EigenLayer as like a restaking platform, but you're using like ETH and ETH derivatives for restaking. Like it could actually basically be any kind of token, at least in my mind. That's kind of how I see it. So is there like, are you focusing on ETH and ETH derivatives, or is there plans to like expand to more different assets? Kind of want to see your view on that.
Yeah, I mean, to attract one quorum and like make it actually usable is the starting point, and I think that's why we start with ETH. But and over time we'll make it totally permissionless. You should be able to stake all kinds of assets into the EigenLayer platform. Even from launch or very close to launch, we will have a mechanism for dual staking, where imagine you're an Oracle protocol and you have a token for the Oracle. You may want both the Oracle token to be staked and ETH to be staked. And both the committees verify the Oracle price, and only if they agree, those price will be considered valid. Right? So there is the EigenLayer protocols already built with this in mind. We call this dual staking or custom staking. Like you can add additional staking in addition to staking, so that you can get the benefits of an insider quorum, right? Like, or your own native token community who actually understand the protocol a lot deeper. But you also have the benefit of verification by a decentralized and neutral committee coming from ETH stakers. So there is some benefit there. But in terms of what kinds of assets, over time, maybe people will stake, or all kinds of assets that are on the Ethereum blockchain can be staked through EigenLayer. Like you can have, any ERC20 token. That's the kind of fundamental construct. And, particularly, I think things like ETH derivatives will be big. Maybe USD derivatives will be big because, and then, there may be things like L2 tokens, like a layer 2 token, like an Optimism or an Arbitrum or a Starkware may have their tokens staked through EigenLayer and provide a bunch of services, not only for their own ecosystem, but also for the broader Ethereum ecosystem. So that is the long-term trajectory. But I just want to mention that there's something special about ETH. And I think that is, there is a cross-network effect between the token of stake and the token of risk. Okay, so what do I mean by that? Imagine that I have two L2s and I'm building a bridge for a service for moving value between these two L2s. And fundamentally, the value that I'm moving across these two L2s is ETH, let's say, or ETH denominated, right? Now, what is my best economic collateral to secure the bridge? It's ETH or ETH derivatives, right? Why? Because it is 1:1 with, I'm transporting $100 million worth of ETH. So if I have $100 million worth of ETH or more staked, then I am secure. So there is a concordance between the token that has monetary premium or is used to denominate risk and the token that is used as collateral on, to secure these services. So this actually, like, in a weird way, even though our platform is general and general purpose and open, promotes the monetary premium of ETH itself, because the more ETH is used as the token of risk, the more the collateral utility of ETH grows in EigenLayer, and the more the use of ETH grows, the larger the value of ETH to then like go and support more monetary premium. So there is this virtuous cycle that I think EigenLayer brings to the table, which is somewhat different from the other types of things that are already there for like ETH. So this is why we think it's likely to, at least for some of the biggest services, bifurcate between either ETH staking and USD staking. Maybe there are a lot of stable coin and like USD denominated transactions that may require USD type backing. There may be other ETH denominated internet native applications that need ETH staking. So that's how we kind of envision this playing out. But it's permissionless, open markets, emergent behavior. We have to see what actually happens.
I love to see ETH grow too. Love ETH. Big fan. Love building on ETH. And that's what I want to get to next. My next question is going to be for Jessy about developers, right? There's definitely a type of developer I see here, which would be someone who's building these AVSs, someone who's building these services that need the validation. And you guys probably want to see a whole ecosystem of those folks flourish. but also maybe even internal to EigenLayer. Are you guys looking for developers in there? And then so that mixture is my question, is like, what kind of developers are you guys looking for? What does your dev outreach look like? What does your dev growth look like? And hopefully I'll tee that one up to Jessy and see what she says.
Yeah, so I think to understand what type of developers are attracted to EigenLayer, we should understand first like what type of AVSs can be built in the first place, and what are the broader categories. So I think we wrote this article, building the next 15 unicorns on top of EigenLayer. There are 5 broad categories that we proposed there. From roll-up services to threshold cryptography to decentralized AI to crypto economic coprocessors to just generalized decentralized networks, right? And I can kind of like break down what each of them mean, right? So with roll-up services, you have DA, shared sequencer, fast finality layers, oracles, bridges, the usuals. But I think as you get to the other categories, it gets a lot more interesting. So threshold cryptography, for example, how do you build TE committees such that one TE is very easy to, expose to side channel attacks, whereas a committee of TEs could be much safer for your network. Things like Shamir secret sharing. How do you split data across multiple nodes around the world for collusion resistant properties so they can actually hold the secret, and release it as demand, right? MPC, right? All these networks. There's also MEV management. Because a lot of the EigenLayer node operators are simultaneously Ethereum node operators. So essentially by opting into EigenLayer, these proposers and actually any agents, I think, on the MEV pipeline from searchers, builders, relayers, proposers can all sort of opt into additional commitments outside of core Ethereum consensus and participate in new forms of, block ordering or inclusion, right? And, things we've proposed like MEV Boost Plus or MEV Boost Plus Plus, where you enable partial block auction, where previously with MEV Boost, the proposers are limited to full block auction because otherwise they will steal the MEV proposed by the builders. But now because these proposers can opt into, hey, I will not steal your MEV if the builder shows me the entirety of the block content. So then I can fill the rest of the block myself. That enables, new promises. And now the proposers can do partial block auction. And that, greatly increases the essentially like decentralization of Ethereum, because otherwise all the proposers will opt into doing full block auction by the 3 top builders, right, in this space. And then things like decentralized AI. How do you run, AI algorithms in the most sort of like trustless way, such that the users can propose some sort of AI algorithm, but that algorithm gets run by different agents as opposed to one agent that sort of like protects the privacy of the algorithm and then also the integrity of it. And depends on how you set it up. But yeah, we also have some like decentralized AI protocols coming up in terms of partnerships and them integrating to become an AVS. And then things like deepen, right? Basically, if you think about it, EigenLayer node operators are just you can be any node operators to become an eigen node operator. And what if these node operators ran different services around the world? And, we have that category coming up as well. Like one of the things I was saying that like is the crazy dream of EigenLayer is if we get to work with Starlink one day and you can run node operators literally in space, right? That would be I think, a really funny and interesting thing to see if that ever happens.
Jessy first mentioned that, and actually there is, I think, a good precedent to this. We have a service coming up on EigenLayer called proof of location, which is basically, imagine you have to authenticate. In Ethereum community, we debate this a lot, like, how do we get more decentralized node operators, for example? And one measure, I mean, there's lots of different dimensions of decentralization, but geographic is one important dimension of decentralization. And, part of the problem is, how does a protocol know that you are in a certain location, right? Like, it's not possible to know on chain that you're in a certain location. What if there was a decentralized node operator set, like all around the world, which is already there on EigenLayer, and they can actually triangulate and send, network pings and messages And then by the amount of time to respond, they can judge how far you are. And when you have many nodes corroborate this evidence, then oh yeah, I know this guy's not in the US. I'm going to pay him some additional geographic dividends for actually diversifying the network operations. And the Starlink is a great example. That's how we GPS works, by like GPS satellites triangulating location across many satellites. So maybe we can have something like that in the future.
Yeah, so basically, I think the gist is, regardless of what type of services you build, there are 3 types of trust that EigenLayer can essentially export from Ethereum, right? Economic trust, decentralized trust, and Ethereum inclusion trust. So a lot of people look at our stake, but that's just one part of it. Where if you're building services that need a lot of high economic trust, like bridges or fast finality layers, right? You can, essentially increase your economic trust by, probably tenfold than what you originally can get. Especially with shared security, the cost of getting these economic security becomes much more affordable as it's amortized across multiple services, right? But that's not just the only thing that we can provide. Like the, decentralized trust, where a lot of services may not require very high economic trust, but they, like threshold cryptography, right? They require a lot of decentralized operators, proof of location, such that you really want to increase the liveness and the like censorship resistant properties of your network, right? Then you would employ decentralized trust. And with, I don't know how many node operators we have, but like we have many thousands, probably tens of thousands, especially with the solo stakers who are opting into EigenLayer. I think we have 900,000 each solo staked onto EigenLayer. So very large set to employ. And then, but last
natively staked. I don't know how many of them are actually solo stakers.
Yeah, right. There's a distinction between the two, but basically we have many solo stakers that are geographically dispersed. And last but not least, within Ethereum inclusion trust, because a lot of these node operators are Ethereum node operators, you could do a lot of interesting MEV management protocols, right? And the other vision that we have is like essentially how to use EigenLayer as a sandbox for experimenting with out-of-protocol upgrades before it actually gets enshrined on Ethereum, right? So that's like the 3 types of trust that you can get from Eigen.
Awesome, man. That's it's a lot of interesting stuff, and it really gets your mind going about like just any of these general, like basically what you're looking for is just general protocol developers, because you're looking for people to build these general protocols on top of this new kind of bootstrap trust, which is just really neat. And so okay, so let's say I am a protocol builder. I have a mechanism I want to figure out. Do I go fork a repo somewhere? Like, how do I start building? Like, what is the actual place to go start building like a prototype on top of EigenLayer?
Yeah, so our team has built this dummy AVS that we called Incredible Squaring, which really highlights to you like how do you build an AVS. To build an AVS, it's very simple. You basically need 2 components, which is on-chain contracts and off-chain node software. And by the way, this is if you were going to build any POS system, you would need these 2. But the fact that Eigen exists helps you abstract away a lot of work in this process. But in terms of on-chain contracts, we've deployed our set of staking infrastructure Eigen core contracts on Ethereum mainnet. All you need to do is to essentially build an AVS registry contract that talks to those Eigen core contracts, as well as a slashing contract. And on the off-chain node software part is basically just the software that you build for the Eigen node operators to run your network, and just make that compliant to the Eigen specs. But yeah, essentially, we have like documentation in our company docs that shows you how do you actually build an AVS, and I can maybe include like a link in this podcast to point people to there. And wait, one last thing is it actually right now we're seeing AVSs building their 2 components within like a month or 2. So it's actually much like faster than people expect. And part of that is because we've abstracted. So for our M2 mainnet launch, which is happening in like 2 or 3 months, we're launching basically not only stakers, but operators, AVSs, EigenDA, and this is without like slashing and payments. Whereas with our M3 mainnet later this year, there is slashing and payments. So basically, we're able to like progressively decentralize and progressively help AVSs build their POS system, and actually to battle test the system. Yeah.
Yeah, you said a lot of things I was very interested in. I didn't know about proof of location. That's very cool. I know like Helium does something similar, like the Helium network. And I come from a networking background, so that was like particularly interesting for me. So I'd be curious to like follow up on that afterwards. But my question is actually to Jessy. Like, I know you have worked with a lot of developers for the past few years in the Ethereum ecosystem, and you were pretty early on with EigenLayer as well. Just curious to see like how you found the team and how you decided to join. Maybe this is like a big, like, yeah, just like now talking to you, I'm like, I need to ask this.
Yeah, I think I have a background with like being VC/running hacker houses, which means I, on average, see hundreds of projects probably like in a few months of span. And I've been in crypto for like a year before I joined Eigen. So I've seen a lot of projects coming through my way, and I have not seen anything that's so interesting, that's so unique. Like you can see a lot of the similar protocols invented out there, but Eigen is like very unique, and the surface area of what it goes through, which I'm actually gonna create like an ecosystem post on. Like Eigen is much bigger than you think in terms of the ecosystem, and like it just, the joke was like, if you dig into any of these categories, you can become like a PhD. And like, it was just like so many rabbit holes that I like, fell into. I wrote like a whole like 4 or 5 page doc on like all my questions and like just my curiosities with like, how Eigen will actually be built and how it would be turned. I don't know. I was just very nerd sniped. And yeah, like even it still stands today. I have not seen anything more interesting than EigenLayer. And yeah, like I think the other thing was Sreeram really has, very incredible presentation skills. Like before I joined, I listened to like 15 of his like podcasts and presentations. And I was like, holy shit, like I've not listened to anyone that can explain something so complicated in such elegant and simple like concept. And part of it was like, he's like trying to build like the coordination engine for like humanity. And I think that is very values aligned, because I've been looking, like what got me into crypto in the first place was because someone told me that crypto can solve trust on like in a massive scale. So that like the whole thing, like, and before I was in crypto, I was in various startups that was trying to solve similar things with like coordination issues and open collaboration. Like how do you bring open source from GitHub to beyond programming, right? And anyway, so all the dots connected. I was like, I'm super mission aligned. This founder is crazy. I actually wanted to listen to what he wants to say. And there's so many rabbit holes. So it all just like, it was like, there's literally no other protocol that brought me the same type of, I guess, joy and curiosity and satisfaction even before joining the protocol. So it just made a lot of sense to me. So
I will say that there is like an aha there for me too when we talk about like building the coordination mechanisms and what Bitcoin is and how Ethereum allows anybody to kind of build apps on top of that blockchain layer. EigenLayer kind of says, okay, well, you can build apps on that like trust assumption or that blockchain underneath it without having to have the token and everything else. There is that similar to me, same thing, like, oh, this is something. Yeah, I agree. Really, really well put.
So exactly, I was like pretty into it for a while as well, but I kind of have a question more on the AVS side. So I know you're building EigenDA, and I feel like it's kind of under the radar with like restaking platform taking most of the buzz. So I'm curious to see like, so there's EigenDA, curious to see what step, like when it will be launching, kind of the view on the AVS ecosystem more so.
Yeah, I'll start with EigenDA, and then Jessy can add a bit on some of the other stuff people are building. One of the people think, EigenDA is some kind of proof of concept, like toy example for EigenLayer, but it couldn't be kind of farther from the truth. We've been working on data availability for 6 years. And you could even say, in some sense, we built EigenLayer to build DA, and just figured out that what is the most general thing is much more useful for all kinds of other things. But that's not precisely what happened, but it's almost close to what happened. And the reason is, when you build a system of shared security, which is what EigenLayer is, which means stakers or operators can opt into many, many services and run it. One of the biggest problems you worry about is scalability, right? Imagine there are 10,000 chains. So the obvious way that somebody else might have built something like EigenLayer is just say that, oh, you stake and then now you run a chain. And as you can see in the word actively validated services, the word chain is not there. This is kind of intentional, because we think chain is a very narrow or like very specific type of an object. And there are lots of other things which are not at all chains that can be built on like a decentralized trust network, a service, something that does like one particular thing, rather than a chain as like a historical ledger with execution and all this stuff. And the one core service like that is data availability. And the reason is, we looked at the Ethereum L2 landscape, and one of the biggest problems in the L2 landscape is the cost of writing data to Ethereum, the cost of publishing data. And the obvious question we had is, what can we do to like reduce the cost of that while scaling it up? And Ethereum had this amazing like research roadmap, right? Has this amazing research roadmap, including danksharding, which is this technology of taking KZG polynomial commitments, take the block, split it up into small chunks, express them as points in this polynomial, and like I can prove to you that you're getting the right point in the polynomial, all this kind of stuff. We said, okay, why not just take that and build, the same technology, the technology underneath danksharding, and then build it as a service that any rollup can consume. That is EigenDA. And what we found is, not being a chain, and other data availability services that people are building are really just new chains. The question that they start with is something different. They start with the question of, what is a minimum viable blockchain, right? And a blockchain just has consensus and data availability. That's a minimum viable blockchain. We don't start with that question. We start with the question, how do we scale Ethereum rollups? And so we come up with a different answer, which is, you should not have to build a chain because Ethereum's already a chain, right? So why would you build the same thing again? So you should build the one thing that is not there on Ethereum, which is scalable data. Can you build a service which is just purely scalable, decentralized data service? And because we're building on Ethereum, we internalize the ethos. And one of the ethos of Ethereum is make nodes light, right? Like, we don't want to have node requirements like Solana and say that, oh, I'm scaling, but each node also needs to have a gigabit per second line. So we internalize the ethos, and then we are now like, it was a constraint, right? The constraint is, oh, you can't have large nodes, but there is a benefit that you have a lot of nodes. So can we build a system that distributes data horizontally rather than across many, many nodes, rather than requiring each node to have a lot of resources? And so that's the core principle around EigenDA. The EigenDA system throughput that we are achieving on the public testnet today is 10 megabytes per second. This is compared to like other DA layers operating at 0.1 to 0.15, something like that, megabytes per second. And Ethereum's native DA server is at 80 kilobytes per second. So that's the orders of magnitude difference there. And we are absolutely looking to scale it much beyond 10 megabytes per second. So the theoretical limits are much higher, and like we want to keep scaling it. And the node requirements stay insanely low. The minimum node requirement to be an EigenDA operator is 0.5 megabytes per second, because no node is touching all the data. This is a core principle of EigenDA. So EigenDA is this like super scalable data service for like Ethereum rollups. We also like thought a little bit about the economics of rollups. For example, one of the problems of being a rollup is uncertain cost structure. Like, data availability costs can increase and decrease based on congestion and other parameters. Can we make it like a guaranteed cost? So we have this thing we call reserved bandwidth, where you can reserve a certain amount of bandwidth just for your own like rollup, and you have that guaranteed. Like, nobody can interfere with you. at that thing at a certain price level. So we have reserved bandwidth. We have the ability for a rollup to pay in their own native token for the DA fees. So they're not taking the exchange rate risk, like, oh, my token's worth this much, your ETH is worth this much. Just natively have a deal to pay in the token, and have dual staking. So I'm building a rollup. One of the utility for my rollup token is there's usually no significant utility, but can I use my token holders to actually, my community, to build and participate in data availability in addition to Ethereum nodes participating data availability? And this is all like core features. So you don't have to do a lot of work to, if you're integrating a rollup with EigenDA, you could have dual staking kind of out of the box. So these are the features that we've kind of built around it. I'll hand it over to Jessy to talk about like some of the other AVSs that are being built.
All I can say is we have a bunch of AVSs already on testnet. A lot of people don't know about it. And we have a bunch of AVSs working towards testnet. A lot of people don't know about it. And we have a bunch of AVSs that we're in chat with. But I mean, like, you have the usual, like EigenDA, Espresso, like decentralized sequencers. You have like price feed oracles. You have like Ethos, basically, exporting Ethereum security to Cosmos chains. You have like these policy engine for smart contracts and networks. Lots of things happening. But you guys will see it when we announce our mainnet soon. So.
Awesome. Yeah, I see a lot of the obvious values and the ahas here, and the huge kind of like Cambrian explosion of AVSs that will happen with developers coming on. And I keep coming back to this interesting, like, there's a complicated amount of trade-offs in terms of, if Ethereum, you were talking about the node needs to be very light, right? We're talking about getting rid of self-destruct so we can not have things get deleted, so then we can have a vertical tree, so then we can have these really hella light nodes. But then there's this, okay, well, if you have to run a new node, and you're obviously thinking about making sure these nodes are very light, but if you have to run a new node, then there's some new requirements that come with this new service. And same thing with the risk. There's this risk reward where I'm running a staking node, but there's the risk of this new program that I'm going to run that could provide it. And so there's obvious value, but you really need to think about the trade-offs. Yeah,
absolutely. And I think the way we think about it is, there are two other worlds, right? One other world is all of these utility goes to, a token outside of ETH, right? Like that's a second other possibility. A third possibility is, no, it goes to ETH, but only LST holders can participate, because you can only you cannot do native staking, because only in native staking we're coupling the operator set kind of more tightly, right? Otherwise, you do, if you allow for like liquid staking, anybody can take an LST and deposit it into any protocol and like delegate to some other operators. So the way I think we think about it is the inevitable consequence of the kind of category of restaking, or this kind of like generalized programmable staking, is the either we have to agree that all value kind of goes out of the ETH token and the ETH ecosystem, or it just goes to LSTs on top. What I think EigenLayer does is to give a third possibility for people who want to retain control of their own operations to still participate in some of the yield and maybe not all of it. And even there, actually, like one of the things that we do enable is you can be a native home staker for Ethereum and delegate your operations for EigenLayer services. So that's an option that's also available. So it gives you this ability to opt in or opt out based on like what is convenient. And I think in the absence of this, I think the emergent scenario is just strictly worse, because without an LST, you are not even viable to do staking. Like that is not a world that we want to see. So, but totally appreciate that, like when you open up a new box, you have all these like dimensions that we are not planned for, and neither do we pretend to know all the consequences of that. But we are trying to take like what you would call a cautiously optimistic approach, where we are optimistic for the new services, but we are cautious that, for example, this is one of the reasons we didn't launch EigenLayer without EigenDA, because DA scales the system. So now you have a scalable DA, so you don't have to overload every node with repeated tasks, at least on the data service. And already we know execution's kind of scaled by like the optimistic or ZK rollups. So you have these two like big primitives, scalable data and scalable compute. And now like people can start mixing and matching these services with the economic security of EigenLayer.
There's a by the way there. I was kind of on a tangent thinking about this. If you could come up with an AVS that proves that someone is a solo home staker and they're solo home staking, you could make some very like that would make the Ethereum network much more decentralized and valuable if you could have some AVS attached to that proves, I'm at home staking, I'm not running or part of some liquid staking, but it's very hard.
That's an amazing kind of like an insight. And what could happen is if there was such a service, other services may come in and say, I only want stakers that are proven against that service, right? So you can create this internal economy and say that for the first time, there is a possibility for decentralized, stakers to earn some special yield because they are decentralized, or even, have an additional decentralization bonus in the service or whatever form that it takes. But this is something we're definitely very interested in.
I just want to add two quick things over here. First of all, I think this is a great point, especially like one of the main concerns I see is like the centralization of the stakers. So like kind of making sure like a lot of people are like home stakers, kind of overcome that risk. But also the risks document, I think you put out like you have an FAQ, which kind of answers quite a lot of like the risks for like both the different players in the ecosystem was really helpful. So I would point people there to kind of look more into it. But yeah, so we are on time. So this was a great conversation. Thank you so much, Sreeram and Jessy, for being with us today. Is there anything else you want to add, like just closing notes, anything we missed, and where can people find you?
Yeah, I think, thank you so much. Really enjoyed the conversation. I'm at Sreeram Kannan, my name straight on Twitter. At EigenLayer is our handle for Twitter. We also have other places, Jessy can point to a few of them. Jessy's muted.
Also, congrats. Congrats on the
I will link them below.
I don't know if you said that out loud. Yeah.